RAG stands for Retrieval Augmented Generation. Let's start with the problem statement. If we use large language model as is, meaning that we use the large language model after it's been trained and we no longer train it further, what we are facing is that it will not have an up-to-date knowledge. If you recall last year when the GPT came out, we know that it was trained only up to a year 2021, right? So that's because the model is used as is or in a frozen state. So it will not have an up-to-date knowledge. It will not have specific knowledge like your company's proprietary document, because OpenAI hasn't been using that document to train the model. And also, if you ask a large language models for some response, it's likely that it can hallucinate, meaning responding in a way that is false, giving you false information with high confidence, and that's not good. So this using the large language model as is fails to answer to some use cases as the following. The first one is an enterprise search. For enterprise search, you don't so the model doesn't have access to your proprietary knowledge or reports or charts, right? So therefore, LLM itself cannot answer for enterprise search, and the same thing as knowledge not in the training data set. Maybe you have very specific specific domain knowledge. For example, maybe you are a lawyer and the model is not specifically trained with legal languages, so it would not know how to answer well. And lastly, if you actually want to make sure or trace back what causes the model to answer to the question like that, the typical LLM will not have that traceability. So as to give you a solid example of what kind of questions are like this, so if the model sees what is our vacation policy, typically the GPT 3.5 would not know, because you never say that what kind of vacation policy your company has. It hasn't seen before, right? And maybe your company has a report about your strength SWOT analysis, and you want to list out our strengths. You want the model to go to the document and list out our strengths. Now the typical GPT will not be able to do that. So the RAG or RAG technique is going to be helping you to actually fulfill these use cases. RAG technique is actually a prompt-based technique. Pretty much, it's going to command or send a prompt to the LLM like this. Answer to a user queries based on the provided context only. And this is the final prompt template of the prompt that the large language model will see. It will construct of the task, which is help users by answering to their questions based on the received context. Now you have to insert the received context somehow, and then you give the actual question of the user and provide that the model need to answer this. You give this to the model, and the model will try to answer within the context. So in the RAG territory, there are 3 steps that you are going through. So let me walk you through all these important steps. The first one is the indexing steps. It actually means that you are creating something that is ready for the model to use. Basically, you will start with a document. A document can be anything like a text file, a PDF, a PowerPoint or Google Doc or Word, whatever it is. You have a document. You need a way to load information from it in order to be processed. For example, if this is a text document, say 100 pages, you might decide that, okay, I want to have one page as one chunk. So each chunk is one page. By the way, you don't need to follow this. You maybe want to have, okay, a chunk is maybe 1,000 words. You can do that too. But basically the idea is you break down the document into several chunks, and each chunk is going to be transformed into what we call an embedding, and this is via using an LLM that is good for creating embeddings. Typically they're called the embedding model. What is an embedding? Embedding is a vector of values, so basically is a string or an array of values. I give you an example here. For example, text chunk 1 is transformed into an embedding 1 using an embedding model. Maybe it will have a result of 0.23, comma, minus 0.8, comma, 0.1, and so on. Other text chunks will need to be transformed into embeddings as well. And all these vectors, all these embeddings will be kept inside what is typically called vector embedding database. That's it. That's step 1, indexing your document, indexing your knowledge. The second step is going to be like this. There is going to be, you're starting with a user query as a text, then you convert that user query into an embedding or a vector using exactly the same text embedding model that you used in the indexing step. For example, this, whatever it is, now the user embedding is 0.22 minus comma minus 0.81 comma 0.09. The step of the retrieval is it's going to take this vector embedding of the query, and it will search inside the vector embedding database for the embedding of the text chunk that is closest to this user embedding. As an example here, as you can see through my example, this vector embedding is the closest to this vector embedding. Therefore, in the retrieval stage, I will retrieve this text chunk number 1 from the vector embedding database. And with this context, I can craft my final prompt like this. I insert my retrieve context text chunk 1 over here and put my user query over there and give it to the LLM to generate the answer. That's it. That's the overall flow of Retrieval Augmented Generation, or RAG, and I actually are going to show you in code. Thank you very much for watching our video. If you like it, leave a comment, and don't forget to subscribe to our channel, Case Done by AI, and see you at our next video.